Okay then, so in the previous lectures we have looked at how to model more and milli state machines. So in this part of the lecture we are going to try to derive our functional block diagram and the ASM chart, okay, given the Verilog code. So given the Verilog code there, let's try and get the functional block diagram of SN3, label all the signals, and then we try to get the ASM chart. Okay, so let's get our notes here. Okay, so this needs to be bigger. Okay, so ASM chart. ASM chart. So what is the step that we need to do to get the ASM chart from the Verilog code given on the left? So first we need to know how many states we have, what are the inputs and outputs. So again we do some analysis. So how many states do we have? So you can see here that according to our standard template, we can see that A is actually your present, the small a, okay, is actually your present state. Okay, so you can see from here that here, okay, this A here is your present state, or as previously notation is a small y. Okay, and B here, okay, B here, B is your next state, or the big Y, as our previous notation. So as you can see here, there are basically two states. Okay, we have a state 0 and a state 1. Okay, the two possible values for our A, because A is 51 bit. So you can see here we got two states, okay, called state 0 and state 1. Okay, so in this case it's a little bit different. Okay, they don't define S0, no parameter. You can see here there's no parameter. It's just two binary encoded state 0 and state 1. Okay, and then we want to see what is our input and output. So you can see there that obviously your C here is your clock and R here is your reset. So your input is actually, you have one input W and one output Z. Okay, where A here is actually your present state and here is your output, and W here is your input. Okay, so now we know that we have two states, one input W and one output Z. So how are we going to draw this? So basically we are going to have the state here. Okay, so we will, if we do reset, okay, so reset will go to state 0. Okay, so how do we know that we reset goes to state 0? So we can see from here. Okay, so we know this. So if reset is 0, okay, we want to go to present state 0. Okay, and what is the output? What is the output Z when we are in state 0? So you can see from here. So state 0, we actually have here is Z equals to 0. It's actually taking from here. Okay, so here you can say that we can put Z equals to 0 inside. Okay, what about the state transition? What about the state transition? So if we are at state 0, we are going to check W. Okay, so what happens if W equals to 1? Okay, so I guess we can see here, if W equals to 1, okay, which is here, then our next state, okay, our next state is actually B. So we can go something like this. Okay, so again, let's go. Present state 0. Okay, W is equals to 1. Then we go to state 1. Okay, so it's just shown here. Okay, so present state 0, W equals to 1, and our next state is state 1. Else, our next state is state 0. So we can go like this. Oops. Some black color here. You can go this side if you want. Okay. Okay, so if we are in state 0 and our input W is 0, then we want to go back to our state 0. Okay. Now we are in state 1. If we are in state 1, we are also going to check our W. And here we can see that if W equals to 1, then we want to set our milli. Okay, you can see here. Okay, so if it's 1, then it goes back here. Okay, state 1, we go back to 1. If it's a 0, it goes all the way like this. Okay, but if it's a 1, we also want to set our output, so we can do something like this. Okay, so here is Z equals to 1. Okay, so I think that's it. I think it should be complete. So we can see that what is happening when we are in state 0, and what is happening when we are in state 1. What happens to the next state, and what is happened to the output Z. Okay, so from here we can derive the functional block diagram. Let's see if we can derive it directly down here. I think we have room down here. So the functional block diagram, as usual. Okay, so you need to remember this template. You're always going to have a next state logic, state register, and the output logic. Okay, and here you're always going to have the reset and the clock. So the reset is called R, and the clock is called C. Okay, so this is 1 bit. We have a 1 bit W, we have a 1 bit Z, and here we're going to feedback like that. And remember that this is a milli machine, so it goes down there. Okay, so here is actually your present state A, and here is the next state B. Okay, I think we should have everything. A, B, C, R. Okay, A, B, C, R, W, Z. Okay, I think that should be it. So let's quickly have a look at our solution down here. Okay, so more or less the same, as a little bit different, but technically is the same. Okay, so here is the thing. Okay, so I think that's done with this part of the lecture. In the next one, I'm going to look at the simple preference controller.